Welcome everyone, and today we'll be solving 10 important questions using laws of exponent. So let's get started. So in any simplification based question, if you find any number which further can be factorized, so first factorize it and write it in the form of base and exponent. Like in this question, 4 and 32 are not in prime factorization form, so further factorize it. So how you will factorize? Using prime factorization method. So 4 can be written as 2 raised to the power 2. Similarly, find out prime factorization of 32 using same method. It will give you 16, 2, 8, 2, 4, 2, 2, 2, 1. Count number of times 2 is appearing: 1, 2, 3, 4, 5. So 32 can be written as 2 raised to the power 5. Now change this expression and write it in form of base and exponent. Now 4 can be written as 2 raised to the power 2. 3 into 32 can be written as 2 raised to the power 4. Now always give preference to first two laws, that is when the bases are same and there's a multiplication operation, add the exponent, or when the bases are same there's a division operation, subtract the exponent. Always give preference to these two if possible. So check the numerator. We have 2 raised to the power 3, 2 raised to the power 2, same basis. Exponents are different, so we will apply law number 1, which says add the exponent. This will give you 3 plus 2 into 3 raised to the power 5 whole upon 3 into 2 raised to the power 5. Now this will give you 2 raised to the power 5 into 3 raised to the power 5 upon 3 into 2 raised to the power 5. If you find any number exactly same in numerator and denominator, try to cancel it then and there. If they are not exactly same, then apply laws of exponent. As you see in this example, 2 raised to the power 5 in the numerator as well as 2 raised to the power 5 in the denominator. So we can cancel this. You will be left with 3 raised to the power 5 upon 3. As there is no exponent, that means 1 is always present. Bases are same. There's a division operation, so we can apply law number 2, which says subtract exponents. And how? Numerator exponent minus denominator exponent, which will give you 3 raised to the power 4, which is further 81 is the answer. How we will expand it? This 3 raised to the power 4 means multiply 3 4 times. Now next question, question number 2. We have bracket here. So solve the bracket according to Pedmas. 5 raised to the power 2 whole power 4. So which law is applicable over here? Power rule, which says power of a power. So multiply it. 5, 2 into 4. One bracket is solved. 5 raised to the power 5 divided by 5 raised to the power 10. Now this can be written as 5 raised to the power 8 into 5 raised to the power 5 divided by 5 raised to the power 10. Now check this bracket. We have say basis multiplication operation. So first law is applicable, that is product rule. Bases are same, add the exponent. We can add the exponent divided by 5 raised to the power 10. 8 plus 5 will give you 13 divided by 5 raised to the power 10. Now again bases are same. There is a division operation. So we will apply quotient rule where we need to subtract denominator exponent from numerator exponent, which is equal to 5 raised to the power 3, and if you solve it you will get 125. which is 5 into 5 into 5. Moving to question number 3. So in this question we have base and exponent, but if you look closely, 25 is not written in the form of prime factorization. So there are two ways of doing it. Either change this 25 as 5 raised to the power 2 and then solve it by replacing 25 by 5 raised to the power 2. Here, power of a power, where we need to multiply exponents. 2 into 3 divided by 5 raised to the power 3. This will give you 5 raised to the power 6 divided by 5 raised to the power 3. Bases are same. There is a division operation. We will subtract the exponent. 5 raised to the power 3, which is 125. There is one more way. As the bases are different, there's a division operation, but powers, these exponents are same. So we can apply this power of a fraction rule, which says when the exponents are same, we will club the bases, keeping the operation same. So here there is a division operation, 25 divided by 5 raised to the power 2. This is second way of doing it. Here you can cancel 5, which is 5 raised to the power 3, that is 125. It includes less number of steps. Both ways are correct. It's up to you, whichever way you want to follow. Moving to question number 4. Here we have 7 raised to the power 6 into 11 raised to the power 8 into 2, as there is no exponent. Now we have 14, and 14 is not in prime factorization form. So first what we will do, we will write it in prime factorization form. So 14 can be written as 2 into 7. Now change it, 7 raised to the power 6 into 11 raised to the power 8 into 2 divided by 2 into 7 into 11 raised to the power 3. As you can see, in numerator and denominator we have 2 exactly same, so we can cancel, right? Now rewrite it, 7 raised to the power 6, 11 raised to the power 8 whole upon 7 into 11 raised to the power 3. Now check numerator and denominator. Bases are same. There is a division operation. We can apply law number 2, which says subtract the exponent. So I am doing it simultaneously for 7 and 11. 6 minus 1 into 11. 8 minus 3, always numerator exponent minus denominator exponent. This will give you 7 raised to the power 5 into 11 raised to the power 5. Can we apply any other law? Bases are different but exponents are same. So here we can apply this power rule where we merge the bases keeping the exponent same, because that is common. This will give you 77 raised to the power 5. Now you can keep this as it is because base as well as exponents are bigger. Now moving to question number 5, here we have numerator and denominator, so we will treat it separately. 3 raised to the power 9 as numerator, but in denominator we can apply law, which says bases are same, so we can add the exponent 6 plus 3, which will give you 3 raised to the power 9 upon 3 raised to the power 9. Now you have exactly same numerator and denominator, so you can cancel it, which will give you 1 as a result. Next, question number 6. Here anything raised to the power 0 is 1, which is our zero exponent law. So 2 raised to the power 0 is 1, 3 raised to the power 0 is 1, and 4 raised to the power 0 is 1. 1 plus 1 is 2 minus 1, which is 1 only. Moving to question number 7. Here also we have base raised to the power 0. So we will replace it by 1. 5 raised to the power 0, 1. 7 raised to the power 0, 1. You can multiply 1 n number of times. Still you will get 1 as a result. Now moving to question number 8. 3 raised to the power 8 into a raised to the power 7, 9 raised to the power 3 into a raised to the power 5. Now if you look closely, 9 is not in prime factorization form. So we will change this 9 as 3 raised to the power 2. So if you rewrite it, this 9 will become 3 raised to the power 2. Already 3 is in the exponent, so it will remain as it is, a raised to the power 5. Now we have a bracket, so we will solve this bracket and apply power rule, which is power of a power, where we need to multiply both the exponents, which will give you 3 raised to the power 6. 2 into 3 is 6. Now if you check numerator and denominator, bases are same. We can subtract the exponents because there is a division operation. 8 minus 6, do it in same steps, 7 minus 5. So this will give you 3 raised to the power 2 and a raised to the power 2. This you can solve it further. 3 raised to the power is 9, a square, and this is your answer. As base and exponent both are smaller in number, so we can expand it. Moving to question number 9. Here all the numbers are in prime factorization form, so you can directly solve it. We have 3, a and b. Directly apply quotient rule because bases are same. There is a division operation. So do it directly in a single step. 3 raised to the power 3 minus 2. A raised to the power 10 minus 7. And b raised to the power 3 minus 2. This will give you 3 raised to the power 1. 10 minus 7, 3 into b raised to the power 1. So finally we can write 3a raised to the power 3b, and this is your answer. So moving to our last question, which says 3 raised to the power 3 into 3. We have a bracket, so first we will solve bracket, where we can apply our product rule. Bases are same, we can add the exponent. No exponent is present, that means 1 is present always. If you add it up, you will get 3 raised to the power 4 whole power 2, where you can apply power rule, which says multiply the exponent. So 4 into 2 is 8. No need to solve it further because exponent is big. You can leave it like this, and this is your answer. Thank you.